Our lesson for today is an introduction to probability. I'm going to start by introducing what's called the law of large numbers, which you are actually going to see again and again. You don't really need to memorize this definition, but I kind of want you to understand what's going on. So what it says is that as the number of repetitions of a chance process grows, you get closer and closer to the actual probability. So I'll give you an example to explain what's going on here. So for example, if you flip a coin, you know that if you flip a coin, the probability that you get heads is going to be 1/2 or 50%. So I'm going to write that as the probability of heads. Notice how I wrote P with a parentheses. That's the same thing as probability of heads. We know that the probability of getting heads is 1/2. Now let's say you flip the coin over and over and over and over again. You do it like thousands and thousands of times. What the law of large numbers says is if you flip that coin thousands and thousands of times, you'll find actually in the long run, you are going to get closer and closer to half of the tosses being heads. So that's what the law of large numbers says. And this actually is what allows us to use probability. So if you flip a coin many times, you'll get approximately 50% heads. And you'll find that the more times you flip it, the closer and closer you're going to get to 50% of them being heads. So let's talk about probability. So probability, the basic definition is that probability is the likelihood that an event will occur. So the other thing that's important is that it is always going to be between 0 and 1. And if you have a probability of 0, that means that something will never happen. If you have a probability of 1, that means it will always happen. 1 actually in this case, remember, is the same thing as 100%. So the other important word is, I actually forgot something important, but I'll give you the definition of simulation and then I'll give you an example. So a simulation is just a way that we imitate chance behavior. You don't really need to know this definition at all, but you need to be able to do a simulation. Actually, though, I'm going to give you another definition. I apologize for not putting it on the worksheet, but hopefully you can fit it on the side or on the bottom. And another important thing is what we call the law of averages. And I'm going to tell you right now that the law of averages is very bad. I'll just write bad. So the law of averages is actually not a real law. People think it's a real law, but it's not. So the law of averages is the belief that you'll get closer and closer to the actual probability in the short run. So for this, an example is, let's say you are flipping a coin and you're trying to get heads. Let's say you flip the coin 5 times and you got 5 heads in a row, or got 5 tails in a row. So a lot of people think that means that the next thing has to be heads, that there's a higher probability of getting heads the next time. And that's actually not true. No matter what, if you got heads 5 times in a row, if you got tails 5 times in a row, if you got all different things, the probability of getting heads will still be 1/2. The higher probability idea is wrong. And if you don't understand the 2 laws, let me know in class, and I'm happy to explain them or give a few more examples of them. So these 2 things, you do need to know what they are. You need to know that the law of averages is bad. And the law of large numbers actually is very important. It's good. It's what allows us to use probability. So for this example, I'm going to talk about how to use a simulation. So in my simulation, I'm saying that I want to choose a simple random sample of size 6 from a group of 60 seniors and 30 juniors, and I write everyone's name on an equally sized piece of paper. But then I change my mind and decide, no, I don't want to do a simple random sample. I want to do a stratified random sample. So rather than getting 6 random people from all 60, I want to get 4 seniors and 2 juniors. However, I really don't want to go back in and try to separate out all the juniors and seniors, so I am going to select names from the bag until I get 4 seniors and 2 juniors. So what I'm going to do right now is I'm going to create a simulation and use the numbers listed below to simulate how many names I expect that I'm going to have to draw before I get 4 seniors and 2 juniors. So when I'm creating a simulation, I always am going to start by figuring out how am I going to label these people. So I'm going to label the 60 seniors. I'm going to label them 01 to 60. If you want to do 00 to 59, that's fine, but I'm just to make it easier on myself, I'm going to do 01 to 60. And the second thing I'm going to do is I'm going to label the juniors. Since we know that there's a total of 30 juniors, I am going to label them 61 to 90. And I'm also, the other thing that's important that you need to remember, you have to mention that you're going to skip any repetitions. You're also going to skip the numbers 00 and 91 to 99. So from there, what we're going to do is we are going to look from left to right. We're going to look at pairs of digits until we have 4 different labels from, so I'm going to look at the digits until I have 4 different numbers from 0 to 60, or 1 to 60. And also, I want 2 different numbers from 61 to 90. The last thing I need to do after I do that is I need to count how many numbers I have. I chose overall from 1 to 90 only. So you'll notice that even though doing a simulation here, actually in the next step you'll see, it's not incredibly hard. The setup is the hardest part. So you do need to write all this stuff out. You do need to write that you're going to label them. So you need to write how you're going to label them. That's this first thing. The second thing is you need to talk about what you're going to skip. You also need to mention that you're looking for 4 different numbers from 0 to 60 and 2 from 61 to 90. So that's the third thing you need. The last thing you need to mention what you're going to do with the numbers that you have. So we're going to count how many numbers from 1 to 90 I looked at. So let's go ahead and do our simulation. So what I'm going to do is I'm just going to go through my table. By the way, you don't need to write this stuff I wrote on the side. I just wrote it for myself for the sake of this slide. So I'm going to start with my number 19. 19 is a senior. The next one, 22, is also a senior. My next number, 39, is a senior. 50 is a senior. I actually now have 4 seniors, but I don't have any juniors, so I got to keep going. I'm also going to do 34, which is a senior. 5 is a senior. 75 is going to be a junior. 62 is also a junior. So I now have 4 seniors and 2 juniors. So I am going to count out how many people. It took 8 selections. So I had to draw 8 names, or 8 numbers in this case, before getting 4 seniors and 2 juniors. You'll find that depending on what random numbers you use, you might get a different thing every time. If you use one set of random numbers or you use your calculator, and the person next to you uses another set of numbers or their calculator, you'll find that you will often get different answers. Many of these types of problems you actually are going to have to do several times. So sometimes you're going to do these like 5 different times, and then you're going to take the average and find out the average number of numbers that you had to choose. But for this one, this was all I wanted you to do. I just wanted you to find out how many names there were, and you drew 8.